Thank you very much, Marwan. I'm very happy to come here and to visit the PII, the talk, and thanks to Marwan who was inviting us. So my name is Khaldoun Al Agha. I'm a professor at University of Paris-Saclay, and also I co-found Green Communication Company with my colleague Victor. So Green Communication is working on networks and edge networking. So we construct what we call the Internet of Edges. It means that we deploy services at the border of the network and not in the middle, like the cloud or somewhere. And those services are very close, so we could have very nice latency, security, privacy, etc., etc. But the problem of the edges is that they are not central positioned, so it's very located close to the users, and it's on a small scale area. So if you want to create something very similar to the cloud, you need to federate multiple edges located everywhere, and this is what we call Internet of Edges. So we create edges, and then everything is distributed, embedded, and then you create some tunnels, for example, like VPN to connect all the edges together and create what we call an Internet of Edges. No need to go to central position. Like, for example, here I'm using Zoom, so I need to send my information to Zoom, and then our people that connect to Zoom to get the information from the servers that are located at Zoom. So Zoom could make a copy of everything. Okay, so and Internet of Edges is different. It means on one edge, for example, or on multiple edges, you could create what we call distributed servers. So you have those servers, you connect to the servers, and connect directly without going to a central position, for example, to use the server who is located in the cloud and not at the edge. And why it's more green? Because when you go to servers, you don't know where the servers are located, so you will travel more. So the bits are going to go maybe for thousand kilometers to come back to the destination. Some agencies, for example, in France, they make an estimate about the average kilometer that a bit of information or a digital object is doing. And the result in average is something like 15,000 kilometers. 15,000 kilometers. Okay? So if, for example, I'm with Mirwan at the restaurant, and he wanna give me, for example, a suggestion for a dinner somewhere, and he will send me this by WhatsApp. I have only maybe a few centimeters of distance between Mirwan and me, but the bits they are going to travel to go to the server of WhatsApp. Assume that the server is maybe in California, and the distance from here to California to go two ways. Okay, one to go to the server, and then from the server back to the user is going to make maybe something like 60,000 kilometers instead of few centimeters. Imagine this carbon footprint, for example, of the digital is huge. Okay? So this is why, for example, putting servers very close to the user is very important to reduce the energy consumption. So this is just a summary of what I'm going to provide like a talk. So let's go to the slides. So the concept of Internet of Edges, so first you need to create the edge network. So this is a kind of mesh network. I mean, it depends. Of course, you could create it with cables, you could create it with everything or materials. But if you want to be fast, for example, you arrive to some area and you want to create something with low energy consumption, with low carbon footprint, for example, you could use in that case embedded devices. Okay, so I'm going to show you, for example, some embedded devices I bring to you. This one is like 300 grams. It doesn't have any power. It's more like 800 megahertz of processor. It contains 256 megabytes of memory and 128 of flash. And on that, you can create networks, you can create services, you can create a lot of things, and you consume nothing. Okay? The PCB is consuming 2 watts. And then if you add the Wi-Fi interfaces and Ethernet, etc., you are around 5 watts. Nothing. If you take any access point that you have, it, for example, in those roofs, for example, you are around 15 watts. Okay? So this is why, for example, with those devices, because they are very light, you could use batteries, you could create like a mesh networks. And then the majority of the mesh network today, they only provide telecommunication infrastructure. They do not provide any services. So most of the time when you create a mesh network, you need what we call a gateway. This gateway is gonna connect you to the cloud to go and to reach your service. So it's a kind of contradiction because you use the mesh network to be independent. You use the mesh network to avoid an operator network, but then you will not be independent from the cloud services. So you lose the property, you lose, the advantages of the mesh network. If you want a real mesh network with distributed services, you need to embed everything on your devices to be completely and fully independent from any external operator. So just remember that if you want to communicate today, you need two different things. The first one is telecommunication infrastructure, and the second one is servers, and a kind of cloud. This is why today, for example, with the 5G, many operators, they understand this maybe today, because in the past, they install like an infrastructure, very heavy infrastructure, and then who is gonna win money with the infrastructure? The OTT over the top, because they use the network as a tunnel, and then you are the customer, and then you will buy services from those OTT or GAFAM, and the operator is only a kind of tunnel. And now they want to modify this operator, they want to win more money with this, so this is why they propose what we call the MEC, mobile edge, in the base station. So this is what we call the MEC edges. And so we are in the same philosophy. So we propose the infrastructure for mesh networks, and then we propose services. So first, we have this network. We also propose services on the network, and then we federate multiple edges that could be located. For example, imagine that you have an edge in Dubai, an edge in Abu Dhabi, an edge in maybe Paris. Then you create tunnels between the edges without any central server, and then you will federate everything. You will synchronize. It means when you do something in one edge, this message is going to be synchronized with the other edges. And that, for example, I don't know if you know, if I take military or public safety operations, so you can have some bubbles, tactical bubbles, for example, and you have the headquarters, or so you could send messages. For example, this message is gonna appear also on the other edges. So this is what we call the Internet of Edges, and today we have even not only research on this, but also products. So we could deploy very easily, edges, and then connect them together to provide those services. So just a reminder, what is ad hoc and what is mesh networks. So basically, ad hoc networks is like direct communication. You don't need any infrastructure. You come with your devices, and your devices connect to each other to create what we call a network. Okay? So it could be with the smartphones like those. But today, if you look to Google, who is providing Android, and Apple, who is providing iOS, they do not authorize that you go to your routing tables, for example, to update your routing tables and create a mesh network with the device. Because you need to have root rights in order to modify the routing tables. So this is not possible. I believe that it will be possible in the future, because today, if you do it, you have one problem. We are not in IPv6, we are only in IPv4. And in IPv4, I could have, for example, one operator, B is another operator, and we could get the same IP private address, so we will have conflict. So it's not possible. With IPv6, it will be possible. And I believe that Android and also iOS is going to provide such kind of services like direct communication, because they already do it, for example, at the application level with AirDrop, something like very similar. But not only, if you look to the AirTag, you know about the AirTag? And also about, if you look to Amazon with the network sidewalk, they use participatory networks like, for example, you have an iPhone and someone losing a wallet with AirTag, they will use your iPhone instead of you. Or also with the sidewalk network of Amazon in the US today, which is operated, we use the rings, the echoes, all the materials that Amazon were selling, for example, in all houses. So you could use this participatory network, for example, to the IoT purposes, for example, for your pets, for your any things that you could have. For example, you could go to those houses, for example, to send information to the cloud. So this is what we call ad hoc. So we could do it today only for robots, for drones, for every material, for example, using Linux, because you have access to the routing tables. So for those things, we are in ad hoc mode. And if we have only, I mean, even for the computer with Linux, you could do it, but not with Windows, Android, and iOS. And this is why we create what we call the mesh networks. It means you have one additional device. On this additional device, of course, you have Linux, and you could make routing tables, etc., and routing protocols. You create the ad hoc connectivity between those devices, and then those devices, they will create an access point, for example, for you. In that case, you could connect to the mesh networks exactly with the same way that you are connected to any access point. Okay? So we could also make a mix of both. You have some robots, for example, some drones, connect to those additional devices, and then your computer, your iPads, your everything connect to the network as for a regular network. So I was working for a long time in the standardization process at the IETF, for example, for ad hoc networks. I was participating to the OLSR. I don't know if you know OLSR, which is a very famous protocol of ad hoc networks. And I was in charge of the quality of service of the routing, and how you could send a message, for example, with the best routes to go from a source to a destination, okay, which is a very, very, very complex problem. So this is the quality of service. So, for example, you will have those devices creating like a mesh network. Most of the protocol today, most of the implementation, for example, of an ad hoc protocol, they will use like an algorithm to calculate the shortest path. The problem with the shortest path is if you want to go from this point to this point, for example, you have some bad links. Bad links. So here, for example, I don't know if you are familiar with the DBM. Imagine that you could discover this link with minus 90 dBm. And those links, for example, are, for example, minus 40, minus 50, or minus 70. So those, they provide a very good quality. And this one is not providing very good quality. And the problem, if you are using like a shorted path algorithm, you will select, I mean, your routes according to a minimum number of hops. So you are going to select, for example, that one plus that one, or maybe this one plus this one. And all the time, you will get something like with minus 80, minus 85 dBm, which is not good, for example, for video, which is not good for everything that needs bandwidth, that needs quality of service. And after years and years of research, I mean, I was creating, for example, something, some algorithms or some solutions with multi-metrics, etc., which is incomplete. But at the end, I mean, when you go to implementation, you can see that it's very hard to implement. And when you implement, I mean, it's very complex. So the time you need to calculate the output, then your network is in another state, and your output is not correct anymore. And this is why, I mean, you need to find heuristic to approach the optimal solution with very simple solution to implement. And we discovered, for example, that the best solution, I mean, to implement a very robust mesh network or ad hoc network is to use the shortest hops. So, I mean, if you have, for example, the choice between this one, you do here 1, 2, 3 hops instead of 1, but in the 3 hops you have much better quality and very low latency, because even if those devices, they do not have a very powerful power, for the routing is huge. So you lose maybe 1 millisecond at the maximum with routing here, and then you could make benefits from minus 40 dBm, minus 20 dBm, etc., etc. So it's better, for example, to use not the shortest path, but the shortest links. Okay? So this is the solution that we implement, for example, today, and it works. It works very, very well. It's like for humans, for example, when you are crying, you will be tired. The other one is not going to receive your voice in a very good quality. But if you are just talking to Jean-Pierre, if I remember, and he's gonna relay, will not only reduce the interferences for the others also, but also benefit from this very excellent signal over noise because we are very close to each other. So you reduce the interferences for the others, and the other will reduce also the interferences on you, and then you will get a very excellent quality. So the only thing is how to detect those sort of hops. So this is our approach, experience, to implement this in the product. So this is for the network, okay? Now we have a network. So you bring those devices, just turn on the devices. Devices, they discuss with each other, like hello messages, topology messages, routing tables, etc. They create the network, and now you have routing tables. If I want to route something for Martin or Martine, so I know, for example, if my next hop is here. Okay? If I want to route something for, I don't remember your name, then I know that G will be my next hop. Okay, so those are routing tables. But now, what we do with the network? We need services, right? So I could, for example, set up a gateway, go to the network to get services. But the other way is how to put services directly on the device. The problem is devices are mobile. I cannot believe on one central service. It's not rubbish. Okay? So I need distributed service. But the distributed service, needs also consensus because everyone has an opinion, right? And how we could deal with those different opinions. It's not only one central point. You ask the service for the central point, and then you get the answer. Here is not the case. Everyone wanna give an opinion. Okay, so we need to, take a decision. And here you have, of course, it's a very, very large domain of research, so many algorithms, etc. So we use like consensus algorithms, for example, based on 2DSP, where you have some votes, for example. So we vote for a leader, and when the leader is designed, then the leader will take decisions. Okay? And one of the first things that we implement, for example, with those distributed algorithms is DHCP. You arrive to an area, you want an IP address. If you have N servers, they will provide you an IP address. But how you guarantee that your IP address will be unique? This is why you need a consensus algorithm. So then we will decide about a leader, and this leader is gonna provide this IP address. And then you have also other problems like the split and merge. Okay? This is a very, very serious problem in the ad-hoc networks because you have a network, and then for some reason, radio, mobility, etc., you will get split or multiple splits, and you will get like partitions. And those partitions will have different leaders. They will take decisions, and then for some other reasons, they will merge. And then those decisions maybe could have many conflicts that you need to resolve. If I take the IP addresses, for example, if you have two partitions, we provide an IP address for node A. We provide an IP address for node B. Those IP addresses are the same. We will merge. We will have a conflict. Those two nodes will not participate to the network before resolving the conflict between the IP address. So today we have all the nodes that we deploy. They have like a DHCP server, and then they talk to each other to resolve those problems. We use it also for the chat and also for the voice. Okay? So, for example, when we deploy, you will get servers to make a chat between each other. So, like WhatsApp, for example, we can send messages, etc. And this is a distributed server, not only one single server. Although for the chat, like a push to talk, or for the talk, we have a push to talk. We can talk to each other, and then when we split, you have the room where we discuss is gonna split to two different rooms on two different partitions. And when you come back, you have a merge, and this room will also merge to get everyone in the same room. Okay? And that's completely distributed, no central server. And then we have also like file sharing, and for the file sharing, we use a different consensus. We use a ghost seed. Why? Because on the file sharing, it's a very special case. Everyone could use the file, could modify the file, and instead of avoiding conflict on the file. Because if I want to avoid conflict, I will lock the file. So in that case, for example, Jean-Pierre will not be able to use the file. He is gonna wait for me, and this is a kind of constraint. So what we do in that case, I leave Jean-Pierre work on the file, me also, and then to resolve the conflict, we do versioning. So we'll get version with GP and the version with K. Okay? So this is why, I mean, when I have something to do with a file, I use it and it can go sleep. So I give the file to everyone to register it, I mean. And then if you have conflicts, we do versioning. It's different from the consensus, for example, if you need to lock the resource comparing to the file share. And then also, since blockchain also is very similar to the distributed applications, so we decided also to implement a blockchain on the mesh networks. Why? It's very important to get blockchain on the maybe you know about blockchain, or you need that I make some summary, you know, for security, maybe for those who don't know about the blockchain. Blockchain is something to provide integrity of the data. Okay? The property of blockchain is to provide integrity on the data. It means every transaction is going to be into a block, and this block will be inserted in the blockchain by making connectivity. I mean, hash. You put a hash in each block from previous blocks. In that case, for example, if you modify one single bit in one block, then all the blockchain is going to be corrupted. So this is why you cannot modify. If you want to cheat, if you want to modify something in the blockchain, you need to modify the whole blockchain. And to protect the blockchain from this kind of attack, we'll replicate the blockchain on all the nodes. If every one of you have a copy of the blockchain, then no one could modify the data. You need to get more than 50% of the version of those replicated blockchain to modify. And this is very I mean convenient for mesh networks. So in that case, for example, when you go, for example, in a mission with a mesh network to deploy, you make transactions, etc., you could put them in the blockchain. You have integrity, and when you come back, for example, to make investigation for some reason, even if it could be, for example, for connected car. Connected car, you have many information that you provide, for example, on accident, on jam, on those information could be just copied in the blockchain for a purpose of investigation later, for example, in case of accident, in case of something. So you know that the data has the property of integrity. Okay? So what we do is we use this distributed file sharing, and we organize it as a blockchain. Every commit, every merge, every transaction is saved in the blockchain. So this is, for example, how it works, the distributed file sharing. You have this mesh network. Imagine that you have a mesh network like this, and then you have people, for example, connected with smartphones, with laptops, etc. They upload, for example, files to that common space, and then so the payload is not mandatory to replicate it on all the devices. You do it only for maybe robustness. If one device is going to leave the network if you have multiple copies, so this is an option. But what you copy is more like the headers, okay, like a kind of index. This index, you know, for example, this file is saved on that device. So when you upload this, everyone in the network is going to be aware about the file. Okay? So you see, it's a common file sharing, like a distributed Dropbox, for example. It's very similar, but in a distributed way. And of course, as I told you, for example, you could replicate this file on other devices. And also you could do it in an optimized way. For example, if someone here connected to the one need to download the file from file, then we'll bring it from here to here by going through maybe multiple hops. Every time you see the file, you could make a copy just to optimize, for example, the service later. That could be an optimization. So we deploy also something on the drones, a distributed network that connects drones directly with also multiple hubs. But also those drones, I mean, they have like embedded service, like the video streaming. So the drones could make a movie, could stream a video that what they are looking for, and then send it over the mesh network, for example, to go to operate. So imagine that you have an operator here. You want to observe what's happening, like from the police, or observe like an area, for example, for security reason or for safety. The problem with the drones is you have like a range. One drone has a range, so like 500 meters. You cannot go more than 500 meters because you cannot lose the drone or the video of the drone. If you use also a 5G coverage, you have also the concept of the coverage. So you need to stay inside the coverage of the 5G or the 4G network. If you want to remove those constraints, you could use like a network of drones, a swarm of drones. And the idea is you come with multiple drones, like N, and those drones, I mean, they have like an intelligence to create a network in an autonomous way. You need only to operate the first one. I mean, you could operate it, for example, with a human, but also you could operate it in automatic way, like an algorithm to go to explore some area and come back. But when this drone is gonna reach the range, then the other drones, they will discover this and they will fly in order to extend the coverage and the range of the drone. So for example, the first one you send it, you have the video. And this video is, you see, you have the range. When the drone is arriving to that distance, you will be out of the range and you will lose the video. And you cannot, of course, I mean, do it manually to send another. You could do it manually, but it's very, very complex. It doesn't scale. So you need to do it automatically. It means the mesh network provides a service of automatic piloting, which is embedded, of course, and distributed. This automatic piloting, so from those drones, for example, one of them, randomly, we will select one of them, and this drone is gonna fly automatically to position itself in between the operator and the master drone to relay. And this position, this location should be appropriate to provide the quality of service, because this video needs, for example, the quality of service, like the signal over noise. So in your service, you need to calculate the distance in order that this distance between that one and that one provide the quality of service needed for the video. And then, of course, I mean, if the second one is out of range, the third one is gonna fly also to provide this. Okay? So this distance between those drones is calculated according to the quality of service that you are requested on that video. If you have, for some reason, interference, for example, here, this drone is gonna go forward, and then you need one more, or for some other reason, for example, the interference is gonna be lower, then this one gonna go rail, and then you will have also some drones that gonna land, for example, because you don't need them anymore. Of course, I mean, you could select any of them as a master. You could take the camera. I mean, take the control of the camera of any of them. There is no difference. Okay, this one is the master because he fly at first, but we will not design one drone as a master. Everything is equivalent. This is very important. I mean, mesh networks. Otherwise, if we are people from computer science, maybe we are people of telecom, so we understand that you could put some signs, for example, on some device. Say this one will turn it on first because you have a DHCP, because you have no. But if you provide those to people that are, for example, making safety, making health, they don't think about it. They don't care about it. So basically, they don't have to do more than turning on and turning off. That. If you ask them more, your service is not going to be I mean, simple to use. And now, maybe 40 years ago it was possible, but now, you know, people, they grow up with this. So everything is automatic. Everything is done by some other people who are making scripts, apps, etc. And the only thing you want to do is payload. I want to receive the payload. I want to send the payload, and that's it. Not control. So, what are the advantages of the Internet of Edges, everything I showed you, and then I will come back again also to some use cases for military and civilians. And so the first one is latency. Latency is very important because, I mean, the distance is very short. Okay? Maybe you heard about 5G. Right? One of the exceptions in the 5G is that 5G could provide 1 millisecond of latency, right? For example, car-to-car communication for safety. Do you know about the distance that the speed lights make in 1 millisecond? 300 kilometers. Only 300 kilometers. The faster that you could do physically is 300 kilometers in 1 millisecond. Most of the time when you are using digital services, you need an acknowledgement, right? So it's not 300 kilometers because you need two ways, send a message and can have an acknowledgement. So it's like maximum is 150. This is theoretically. In practice, maybe you have some delay here and here, the antenna, signal or noise, etc. The other, let's say 100 kilometers. Do you think that today the cloud provider for a service could guarantee to you that the server will be closer, less than 100 kilometers? I don't believe this. It's impossible. For everything with a low latency, like car safety, like, for example, surgery, operations, etc., you need to use edge. It's mandatory because cloud is not able to provide any guarantee on the distance to still before inferior to 1 millisecond or maybe 5 milliseconds. So this is why today many companies, for example, like from the GAFAM, from everywhere, I mean, they are providing edge services, you know, Microsoft, Amazon, etc., because of this latency, because now more and more we have services that need low latency, many services. The second one, of course, I mean, you have mobility. So the mobility is not only in the services, because today you have mobility on the service, I mean, on the user, but the network is not mobile. With this, you have also mobility on the network. Your edge could move with you. That's could be an advantage for many use cases. You have also security and sovereignty, okay? Because everything is at your side. If you have very sensitive services, for example, you just remove the gateway. And you are with a kind of lockdown system, okay? When you have COVID propagated everywhere, what you do is you close the border, right? No one come inside, no one go outside, and then you will protect yourself. And here is the same. You have like a cyber COVID coming from the gateways. What you do is you stop the gateways. But today we cannot stop the gateway because I cannot communicate. All the services are behind the gateway. If you do edge, you will get everything inside your edge, and you don't need to go outside. It's more like a comfort position more than mandatory. And of course, I mean, for the data, you have the data. Everything is inside also. So this is why, I mean, you could have data lockdown. You could also create blockchain, for example, for this data in order to provide integrity, etc., etc. And of course, I mean, today we are working on scalability. So we could provide like mesh networks, for example, with 30 hubs because of our optimization in the implementation. But also we do, as I told you, edge synchronization. Because the problem of edge, you put it in PII. You have another side of PII, so we could connect each other, of course, through an VPN. In that case, you have, of course, the gateway just to connect, but not to go and to reach the servers far away. And of course, it's very low impact carbon because no travel, services are very close to you, and also you use embedded devices and not powerful devices. So this is a kind of deployment. As I told you, we could do hybrid between ad hoc and mesh. Okay? So for example, if you take robots or drones, we have the control. I mean, it depends on the drones, of course. If you take DJI, everything is closed. You cannot go inside and put something. The example that I showed you, for example, we use drones from Paris. And Paris, at that time when we have done this prototype, drones were open. We have like a telnet service. We go inside the drone, we put our device, our code, and we recompile the system to provide the mesh networks. Today it's more difficult. I mean, I'm talking about drones for everyone, but if you use professional drones, most of the time you have an SDK to put something inside the drone and to have access to the routing tables, for example, and other daemons. I mean, in the robot also. But if you are using like smartphones, for example, in that case, you need like devices like those and provide like an access point. But it's very similar. That then just you need those additional devices. You enter the network, you will get an IP address, and then everything is IP. So you could have access to the output. So this is how it works. So you have the services here embedded. It could be used, for example, for IoT, for drones connectivity, robot connectivity services, and URL terms. And then, of course, if you need to go to the cloud, to synchronize with the cloud, it's possible because you have a gateway and it's an IP network, and IP connect with other IPs, and no problem for this. So this is what we call edge synchronization. So you create those tunnels, okay? So you have this internet of edges. And of course, as I told you, I mean, you could go to the cloud. If you want to, for example, like take a virtual machine and a cloud provider, is not prohibited. It's just up to you. It's an option. So it's very easy to do it. You create also secure tunnels, and then you have this VPN server to synchronize everything. This is how it, I mean, I'm gonna make a demo. Then you will just see something very similar to that. So every service is in the edge to avoid also that you have constraints. So what is the constraint? To use a service, you need an app, right? So the app, it means you wanna go to App Store or Google Store to download the app. This is the constraint. If you wanna work with completely lockdown, for example, system. So this is why in avoid, even for example, you bring your phone, you lose it for some reason, we give you another phone, you don't have time maybe to upload or download all the apps. So this is why we take the decision, for example, to embed the web server, distribute web servers, and to provide everything under web apps. So you need only browser, a web browser. You connect to the web browser, you have like a local URL. You connect to this, and then you will see all the services that are provided locally, and then you can use them. Of course, it's open. If you need to add new services, for example, you could do it. So as you can see, network is completely independent from any operator. Services are completely independent from any cloud provider, and also apps are completely independent from any store, because you have the apps embedded directly in the system. This is one of the use cases that where we use what I was talking about. For example, you have those robots, okay, containing the software, and the soldiers, for example, they have more like devices to connect to the network to get the information. So what they do, for example, they send those small robots before intervention, for example, to explore everything with a video. As for the drones, you remember the drones? They use the same system. We could send one robot, another robot, another robot. They go inside buildings, etc. They explore, and then if no one is here, then soldiers come. Okay, so what they could be killed, for example, with some people who are inside the building. And this is more like a IoT deployment that we are doing now. So it's to this deployment is done to be more comfortable in the work. Okay? You have some work that is very hard. For example, labor. They need to take, for example, heavy things. So what they do, I mean, our partners, they put cameras, for example, to observe posture, etc. And then if something's wrong, they will send a notification on the smartphone to say, okay, this is not good. You need to optimize how to hold those heavy things. It could be also for people working in offices like you. After 10 hours of working, for example, so cameras will see that your eyes are not in an excellent health. They could see, for example, that you are very tired. So we are going to send you a message, a notification to tell you that you need to take a break. Okay, now we could close everything because the performance is very low. It could be in a car, for example, observing it. And since it's very sensitive, even the headquarters of the company do not have the right to access to the data. Okay? To avoid that, make judgments on the employees, for example, it's only for the comfort, okay, to optimize the work. So this is why, the network couldn't be deployed on the main network of the company, because the IT department of the company could maybe take the data and to give it to the headquarters, etc., etc. So we didn't enter in that circle. And also, the IT department will have also some problems to include external services. This is why we decide to deploy everything on the fly with a mesh network in the company. In a factory, we have two deployments. One in an insurance company, one in a factory, and the other in an IT company with teleworkers. You see also we make Internet of Edges with teleworkers. So you have this mesh network, okay? Those devices, the number of devices will depend on the server. It could be 5 devices, 10 devices, etc. Then I told you that we don't have maybe enough power here to make like AI, cameras, analysis, etc., etc. This is why you have the opportunity to add edge servers. Edge servers here, for example, like Intel server, etc. They connect to the network also with cables or with Wi-Fi anyway. So everything shares the same IP network. Then you have those devices. So some devices, for example, they connect directly because they are IP components. Some other devices, they do not have any IP components because Internet of Things, you don't have enough power, etc. So you use what we call IoT gateways, like everything Bluetooth, for example, they need an IoT gateway. And then, as you can see, the camera is watching someone, going to send the stream here to the server analyzing. He sees something wrong, he will send notification to the smartphone to say, okay, go back, go home, you are very tired, or excellent, etc. And no internet connection. This VPN is only optional because with the COVID, we cannot deploy remotely. So we deploy and then partners, they could go to the network just to fix bugs, to install, to verify that everything is working okay. And then we stop the gateway and everything is working in a lockdown system. So this is with the teleworkers, So on one company, they have many teleworkers. So all the experience is based on a volunteer. Okay? All of those are volunteers. They take even cameras and sensors, for example, at home. They put them at home, and then the camera and sensor are watching the people working, etc., and then send notification to say, now we have to stop, now we continue, etc., etc. And as you can see, those here you have a different side of the company. Here you have teleworkers, and here you have the main, you have the VPN, and everything is gonna be connected like an Internet of Edges. And even the partners who are providing services, for example, they could connect only on their servers, not on the server of the others, because RGTV, etc., etc. So every partner will have a space which is different of the other. In those servers, for example, this is one server per partner, no sharing resources because of sensitive information. And now we are doing the same thing in a hospital. We are starting working on a kind of a new thing like a collaborative artificial intelligence. It means you have multiple robots in the hospital. Maybe with the COVID crisis, we have seen that hospitals didn't have enough resources, human resources. So now more and more we need to deploy robots. So robots, for example, they could provide drugs to patients. They could inform, etc., etc. So we have the hospital are a very huge space. So we need to have optimization, for example, that robots could work separately. And what we provide today is like a mesh network in order that robots connect to each other, or to the infrastructure. For example, it could be infrastructure like this, or even this is ad hoc, this is mesh, And then, for example, to converge faster in the intelligence, robots, they will send the knowledge and learning to each other. And the problem then, you will have the problem of consensus, because everything is not synchronized. So you could have two different solutions coming from two different robots to enrich your knowledge. This is why you need to have a consensus algorithm in order to decide what knowledge you are going to update trying to take. Okay? And of course, I mean, in the hospital, we use also the blockchain because everything that robots provide is going to be a transaction registered to provide integrity. And this is, we provide also an interface, for example, to in order that if you want to see the blockchain, for example, how it works, etc., you could see, for example, that we have some split and merge, etc., in order to converge finally at the blockchain. Every transaction, every file, every block is registered. You have like a graphic interface to watch what's happening on your blockchain.
I just wonder how you see the mesh network you can deploy into a 5G because or any cellular network, because traditionally your data for the user plane will come from RAN to transport to core networks, and usually you have one or two core networks in whole city. Of course, 5G now we have the NEC, which is implemented like mostly in the private campus network that close to your base station, close to RAN. But how to see that the challenges if we want to make a mesh, I mean, within inside, especially in the radio access network, and also in your deployment, you will see that you have one edge server connecting to all the access points, but you still have the delay. You have to fuse all the data into the edge server. Is it possible in the future that you have this edge distributed into the access point that you may be further reducing these delays and computing? And especially when you have mobility in the mesh, you may have the challenges that your data is not synchronized with the other stage. Then how you see the challenge to overcome this? Thank you.
Yeah, for the 5G, all right? The first question was 5G. So 5G today, basically in the specification, they provide like the direct communication without going through the access point. It's only in the specification. So now there is not, I don't see products. I mean, I have seen some products, for example, from Qualcomm, and Kestel also was integrating this product for the ITS. But I mean, I tried to buy this product to see what is the strategy, what kind of things to do with this product. And I never success to get this product. It's more like for communication or marketing. Anyway, so today I'm working for everything I presented is in IP. So under the IP, you need an interface. And this interface should provide the direct communication. If you don't have an interface providing direct communication, it will not work. So today, the only interface which is complemented with IP that provides this interface is Wi-Fi. With Wi-Fi, you could do device to device without going through an access point. So in that case, you could make like a mesh networks with the Wi-Fi very easily at the IP. But of course, I mean, 5G is gonna provide this because of the car-to-car communication. But maybe we need to wait two years. And then when we have it, I mean, everything that we deploy in the Wi-Fi will work with the 5G. So this is the first question. So I believe it's gonna come. And the second one is for the service. Services could be deployed everywhere, of course, in the access point of the operator, and even in the boxes. But also, I mean, as I told you, I believe that we will put services here, even in the future. When IPv6, I don't know what is the case in Emirates, but in France today, 99% of the phones, they have like an IPv6 address. So it means in maybe 1 or 2 years, maybe 2 years maximum, all the mobile system will switch to IPv6. So we will get public addresses on the phones. And in that case, we could deploy. Why we could not deploy today services on the phone? Because we don't have public address. If you are in a private network, you could have today, for example, I could put a server on my camera. So I could stream with my phone, and all of you could go directly to the camera to see what's happening without going to like a YouTube or any server in the cloud. It works already. But the problem is you have private addresses. So with private addresses, I mean, services here cannot work. I need public or what we call the port forwarding. You know, the port forwarding, it means you have a public address on the gateway and then you forward all the traffic. But I mean, operators, they cannot do this. It's not scalable. They could do it for 1, 2 guys, but not for million and million. I mean, each guy who want to create a service, he will contact the operator to make a port forwarding. So it's better to go through IPv6. And then what's happening, if you have IPv6, you could even do what we call hybrid networks between the horizontal communication and also the vertical communication. I already done this, for example, for the Marine. They go, for example, to inspect for boat inspection. Okay? So they have like a suspicious boat, and they need to inspect it. So they send a commando with a small boat. They arrive to the suspicious boat. They go inside. They are connected most of the time because we have like 20 miles, about 40 kilometers, for example. Connectivity with private 4G, and in the future maybe private 5G. But the boat is more like metallic boat. You know, you have a Faraday and all the signal. I mean, that are not going to go inside. So this way we do it hybrid. It means you have two interfaces. One is 4G and one is Wi-Fi, and you have two different links. The one to connect to compare. We are the commando, for example. 4G is going to the base station and come back here or direct. And then the system compare in terms of quality, what is the best one. And then if, for example, we are inside the boat, we have weak signal with the 4G or even not having any 4G, then we will use the Wi-Fi. If you are, for example, far away from each other on the boat, for example, and the 4G is better because they have higher power, so then we will go with the 4G. So this will work. I mean, it's only a question of identification of the node. And IPv6 will resolve this problem in the future, and we will get more and less like hybrid services. So a building could create services at the edge, and then connect this in a hybrid mode with the cloud.
Hi, Khaldoun. The question is, this was probably not the purpose of the talk, but you didn't talk too much about security. What is the important security aspect on the mesh that you think we should push forward? Let's say.
I mean, if you need a complete security, then physical security, you could work without glittering. Mm-hmm. That will happen, and then you will get maybe some problem with the inside the network. So this is why, of course, I mean, you can set up all the security mechanisms. So today, for example, you have a very strong security on the Wi-Fi. You have that UPA3, which is a very good security, and then if you connect between services, you have HTTPS, which is like API. So you have like a public keys, private keys, etc., in order to share between the applications. We use also SNMP with the private auth, which is a security also on the SNMP. And then you could add also tampering on the tunnels, even between the nodes. I mean, it depends on the degree of the security you are looking for. If it's like military, if it's like very important things, so you could add its IP. In IP today, you have libraries, you have many algorithms coming from the cryptographic domains, you know, that you could apply. For example, even many people, I mean, in the open source community, they developed many libraries, for example, to provide you AES, etc. So this, since you are IP, you could use all the security that you use in the internet, apply it in the networks. Whereas an additional nice aspect of the security is that you could stop the gateway and you are completely isolated from the other.
Having been in this this business for a while, I actually, when I started doing research, I was at the top of the distributed system. No, it was the keyword, and everyone had to do distributed because centralized was the bad, the evil, and so on. Then cloud came back, and we started doing centralized again. And now then there was fog, like something in the middle, decentralized, and now distributed again. Do you think that we will decide for one at a certain point?
No, I don't think so. I mean, we go from look to SDN, etc. So we go from distributed to centralized to distributed to centralized. But if you look, for example, in the years 80 now, we make a lot of progress. So every time we move from one concept to another concept, we make benefits from a lot of research, a lot of implementation, etc. So today, if you look to the cloud comparing to the mainframe, remember the mainframe, you don't have the same services and also distributed. Long time ago, it was not very easy to deploy, to use, etc. And now it's the case. So each time, I mean, we need, of course, I mean, to put ourselves in the centralized, and then we see the drawback of the centralized because it's distributed. Then we see, of course, the best way to work is really in hybrid solution. I mean, as my answer to the first question, I mean, is to have both, and then we make benefits all the time from the advantages of both. Okay, so centralized solution, most of the time they give you the best solution, but they do not scale. So if you use at the same time, it's like today the SDN, you know, SDN, they are controlling maybe routers, but not more than 50 nodes. over the 50 nodes, you come back to the distributed and you work like this. If you look to internet is maybe the best success in the distributed system. And today, if you have like a bug, if you have an attack in an internet, the whole network is not down, only a part. So this is why, I mean, you could create a mix. When you want to scale, it's more like distributed. When you have mobility, you have constraint of the point of failure, you have distributed. If you don't have those constraints, for example, you can come back to the cloud. And the new thing today is the climate change. So we need to, everyone is integrating this because, as you know, I mean, temperatures are growing more and more, and we have problems, etc. So many governments also they creating the laws, for example, to provide your footprint. If it's very high, we will get a fine. So distributed, I mean, if we could do everything directly, it's better than going to the central servers and come back.
Thank you very much for wonderful presentation. I want to ask regarding some question regarding the blockchain that you are using. So it is very interesting to use blockchain in the mesh network, and we are envisioning to use the same. My question is how you are ensuring the finite time concepts in the mesh network when using blockchain, and which type of blockchain are you using, like permission or public, or any mesh node can join at any time?
So the blockchain that we are using here is more like permission. So only people inside the network could participate in the blockchain. And this is why we use the consensus. I mean, because, for example, make a vote. Otherwise, you need to use like proof of work or something like this. So this is more like a consensus, and you could modify it. The blockchain that we use is more like a transaction that we take. Consensus and blockchain are different. Okay, blockchain is more like putting the data in blocks, and each block is referring to other blocks. And how to validate the blocks, then we use consensus.
Consensus, yes, exactly.
As I told you, I mean, what we use is a very simple one because it's convenient to the file sharing. Is the process with versioning. So it could work also for non-permitted blockchain. But since I mean you cannot upload data without entering the network, so you need the credentials of the network. But I mean, of course, it should be non-permitted because every routers, when he decides to make transactions in the blockchain, he will do it. And if you have a conflict, you make versions, different versions.
So the forking you are handling through the blockchain versioning?
It's not, I mean, the fork is only when you have a split and merge. Okay? If you have, for example, n nodes, and you have then n plus k, then you will have like a fork. And then when both converge, because you will send your blockchain to the other, it's integrating your blockchain, and then you will come back to a blockchain, a normal blockchain. So the fork will be only like in the middle, and then you come back. It's like a draft. You know?
Okay. Yes. Exactly. Yes. And is there any effect of number of hops when you show the drones are relaying the data?
Yeah, today you will have an overhead. Every time you have more nodes, you will have an overhead because of error messages, so 50, etc., etc. So the maximum that we have done today is 30 hops.
12 hops. 30.
After 30, I mean, you will spend your time to send messages. So it's better maybe to clustering the network than doing something. I mean, not clustering is like internet today, you know, with maybe 1 billion of nodes in the world. But it works with cables, you know. So the cable is not, and also it works like clustering, you know, because you have BGP, which is just telling, okay, all those domains are that way. So it's very similar to internet. I mean, so you create a network, and then you will just have a gateway and to cluster to the other.
Thank you very much.
Okay, thank you very much. So I turn on my devices. So this is the device, you know, it's very light. We are not producing the hardware. Hardware is off the shelf. We are buying it from a US provider, and then we just put our software inside, and then we have two Wi-Fi interfaces, minus 242. This is the Wi-Fi 4, and now we're just moving to Wi-Fi 6 a few weeks ago. So now we have even products with the Wi-Fi 6, which improve the bitrate and the quality, but the problem is the heating. So because Wi-Fi 6 is more powerful, so they work more and more than Wi-Fi 4, so they heat. So for example, instead of putting two wireless interfaces, you put only one Wi-Fi 6. But now you have like a technology with DVC, dual antenna, dual connectivity. So with only two antennas, you could provide two different networks, one in the backbone and one in the access point. But still, with only one interface, we have more heatings now than interfaces with Wi-Fi 4. Anyway, and this is the battery. So I take a battery because it's 4 ampere hours. Okay? I couldn't take 10 ampere hours because it's probably take it in the plane. The maximum is 100 watt hour, which is 12 volts and 10 ampere, 120 watt hours. So I drink only. This one is like for about 9 hours of the economy, and the 10 ampere hours like about 20 hours. For example, if you have a split, I create a room, for example, like TII. Okay? We create TII, we discuss, and then I will leave, and then we have a split. So TII will stay activated in the two partitions. So the one where the server is, no problem, continues. The other one, consensus will create a new one. And then when we come again, we'll merge. We will have a conflict. So the same room is a free with two different servers in the same network. Then the consensus will decide who is going to host the room. And then it's not easy now to implement. So at the beginning, when we started, maybe the first distributed application that we have done was DHCP for the IP addresses. So we included in the DHCP. Then we decided to take it out and to create a generic consumption algorithm to provide like a root reader, for example. And now we use it for many applications like DHCP, chat, Toke, and very soon it will be video streaming, etc., or video conference. So we are progressing by enhancing the service more and more. The service itself, but of course, I mean, you could add services also in a different way. And this is like this one. This is another way to make services with mobility. So this server, for example, could be in a battery. You could move. So you have the service here. If this one, for example, is here, you will connect to the other one, and service could continue. It's another way, less robust maybe, but it works also with mobility. You don't have to just say this one is the server. Because the server is gonna connect with handover. Server is gonna make a handover, and it works, of course. So sometimes, for example, we work like this. People, they buy our products, and they do not have the competencies, for example, to distribute the services. They do not have maybe the time or even to ask us to do it. So then we use this option. Any other questions? So basically, everything is booting. Another thing is that we could create profiles for the device management on the network. So we define what we call V card. You know about the V card? It's like an IETF standard to create. This is what you use, for example, in your mail signature, for example. It's a standard from the IETF, from the internet. And the advantage of the V card is you could put any field you need. So we associate this to every device connected to the network. In that way, for example, you could create a V card for a drone, for a robot, for Jean-Pierre, for me, and you could put pictures, you could put a link, for example, to stream the camera, you could put temperature, you could put a lot of things, for example. And you have like what we call a management interface, for example, to see where are your devices, where they are connected, etc., etc. And also, for example, you could put some location coordinates. In that case, we could display a map, and you could see even geographically where are your devices, for example, from this single interface. The other thing which is distributed is also the setup, the controllers. You don't have a dedicated machine to, for example, control your network. From every device, you could connect with every other device, like a smartphone, an iPad, a computer, you have just an administrator credentials comparing to the others, and then you could change your frequency, password, etc. in a distributed way. You don't need, for example, to put like a headquarter of IT everywhere. You connect to the network, and then you could manage it even from remotely, for example, through the VPN. So if you want to connect to the network, basically you have the network called community demo. I put a very simple password just because it's easy to connect. And then you open a browser and put this URL, and you will find all the local services. And then we could do mobility, of course. And if someone want to go, we will see that he will make a handoff. As you can see, we'll go there. And then if I do my network, you can see 3 nodes, many people connecting. You will see that I have a vCard. You will see my picture, for example. I could do in real time a vCard for someone. If there is a volunteer, I could take a picture, upload it with my administrator interface. You will see the picture appearing directly on the interface. And if you click on my picture, you have an eye, and then you could see, my vCard, like my phone, etc. I put some information, for example. So this vCard could be much more longer than this. By default, we have put also like a tool server. You know about tool servers if you wanna like OpenStreetMap or etc. So we put like IGN, which is a French free maps. I don't know if they operate in Emirates, but if you put a gateway, I don't know if you have filtering or not, but if you have like an Ethernet and just plug here, we will connect the network to the internet with no problem.